Okay, so we're done learning about how to name covalent compounds. You know everything you need to know. Okay, use prefixes, and that's it. Okay. Do we remember generally what types of elements will bond to make covalent compounds? Metal, metalloid, non-metal, like based on those categories? What? I hear mumbling, but I can't understand.
Hey, look like I'm in the bathroom. It's brand new too.
Cool. Let's talk about chemistry.
It's even green.
What types of elements will bond together and make covalent compounds?
All of them.
Did you say non-metals?
It's not what I said.
Why is no one saying
Non-metal and non-metal.
non-metals? Oh my goodness! Wow, this is painful. Non-metals and non-metals. Okay. Basically, every compound you just did on this fan and pick, okay, was all non-metals. None of those elements were metals. Okay. So now we're going to turn our attention to ionic compounds, which are going to involve metals 98% of the time. Okay. This is an entirely different naming system. Okay, so I don't want you to forget the other naming system, but I don't want you to confuse it with this one. Notice the slides change colors. It's a different system. Okay, and so we're going to look at different kind of subcategories of this. Okay, so ionic compounds, we're going to have a metal and a non-metal for the most part. Okay, we're going to kind of think about this in two different categories, and we're going to cover the first two today. Okay, so we can name ionic compounds that come from the main group elements. Do we remember what the main group is, as opposed to the transition metals?
1, 2, and then 13 through 18.
Yeah, perfect. So groups 1 and 2, and then 13 through 18. Okay, those elements will generally form ionic compounds when they bond together, and they will be named slightly differently than if we have a transition metal. Okay, so we're going to address these two kind of subtypes here, and then probably next week we'll talk about polyatomic ions, which will be super exciting. More things to memorize. And I've actually kind of changed how I teach this, and I think it's less confusing this way. So, well, okay. We're going to get to the polyatomic ions next week. We're just going to focus on this element bonding with some other element. Okay? So, let's do this thing, okay? So the first thing I want to talk about is how do you name an ion, okay? We are not going to use prefixes, okay? There's no di, tri, tetra, none of that. That's only for covalent. We're going to look at ions now, okay? So, if I have an element that is a cation, and it's in the main group, I'm going to just use its normal name, and I also know its charge, okay? So for example, if I have K+, I'm just going to call it potassium even though it has a charge. So potassium as a neutral element and as a cation is just called potassium, okay, for this naming system. Okay, if I have a main group element and it's an anion, I'm going to use the IDE ending. Okay, so negatively charged ions, we change the ending. Okay, so oxygen implies a neutral oxygen atom. If it's negatively charged, I should call it oxide. So for this, we're implying a charge by changing the ending. Now I said if we're in the main group, the charge is automatically known. Do we remember the pattern from the last chapter of how the charges work for each group? I said, so every element can be neutral, but for some compounds, when they form an ion, they tend to form the same charge if you're in the main group. So these first two columns and then these last 6 columns tend to form the same charge depending on the group we're in. Do we remember the pattern? Plus one is right here. Oh yeah, it's based on the valence electrons, right? We're trying to get to a noble gas. These guys like to be +1, So in this column, typically, and then what was the next one?
2.
Plus 2. I'm going to skip the transition metals because they're a little more complex. They don't follow this pattern. But we pick up here,
3.
plus 3.
Plus or minus 4.
Could be plus or minus 4. Okay? And then negative 3, negative 2, negative 1, and then 0 because they don't really become ions. Okay? So if I just say sulfide, you automatically know, oh, sulfur, he used the IDE ending, it's negative, it's probably a negative 2. Because I know that sulfur is in this column, the negative 2 column. Right? You'll start to pick up on the pattern. If I say fluoride, that's F minus 1. Right? Okay, nitride, phosphide, chloride, bromide. Okay? The IDE ending implies the anion version of those elements. Okay? So, yes, so that's a reminder from the last chapter. Okay, so when we're naming these, we're going to use that system for the main group, okay? Now, for transition metals, we got to do something a little different, okay? Because of the transition metals having valence electrons in a d subshell, and for complex reasons I won't go into now, they can actually become ions of very different charges. Okay, so if you take like iron, for example, is very commonly a plus 2 ion, but it's also very commonly a plus 3 ion. So if I just say an iron ion, it's not clear what charge it has because it's very commonly lots of different charges. Chromium is pretty crazy. Chromium can be anything from like a negative 4 to a positive 6. Okay, and so I think copper also could be a plus 1 or a plus 2. So we need a little more specificity in naming those. If you're in the main group, there's only one charge, so you just kind of know it. With the transition metals, we need a different system. Okay, so we're going to explicitly state the charge in the name when we're naming a transition metal that is an ion. Okay, so the way we're going to name it is with Roman numerals. We're just going to say the charge. It's going to be fine, I promise. Okay, so iron with a plus 2 charge is called iron 2. Iron with a plus 3 charge is called iron 3. Okay, and if you want to be super technical, notice there's no space there. It's all just one word, even though there's a number.
What if it was negatively charged?
If it was negatively charged, we would call it something different. However, the compounds we're dealing with, the metal is always going to be positive because it's bonding with a nonmetal, and the nonmetal is the one that's going to be taking the electrons. So we're not going to run into that.
So what if it's a negative charge?
It won't.
Promise?
Is that what you just said?
Drew kind of just asked that question.
I
So.
can't hear.
It's okay. Short answer, it won't. The metal will be a positive charge if you're bonding with a nonmetal because the nonmetal has a higher electronegativity. Okay. Fair question.
I was thinking about iron too. On our lab.
Oh, yes. You saw this in your lab. You saw iron 2 chloride and copper something nitrate. Yeah. It was me naming what it was. Yeah, exactly. Okay, so we only use these Roman numerals for transition metals. Okay, back a few slides when I said potassium, potassium's in the main group. I don't need to say potassium 1, that's redundant. Everybody knows potassium is a plus 1 because it's in group 1 and it doesn't do anything else. Okay, so we only use this for transition metals. Okay, now, what Roman numerals do we need to know? Well, only up to 10 is really all we need to know for this. Okay, so in case you don't know your Roman numerals, here they are. Okay, 1 is a line, 5 looks like a capital V, 10 looks like an X. Okay, and you combine those symbols to get the other numbers. Okay, so 4, if you think of it, it's like 1 before 5 is kind of how I think of it, is 4, right? 8 is 3 after 5, or 1 before 10 is 9. Okay, so that's kind of the logic of how I think about it. So we'll need to know these as well so that we can name transition metal ions appropriately. Cool? Okay. Technically, there's a few other elements that need the Roman numeral. So there's these elements over here. These are called post-transition metals. Yes, they're in the main group, but they're below the, what am I trying to say? They're below the first D subshell. Okay, so gallium, indium, tin, thallium, lead, bismuth, and polonium will need a Roman numeral. Aluminum doesn't have any D electrons, so aluminum doesn't fall into this. Okay, but these heavy metals down here that are post-transition metals also will need the Roman numeral. The only thing you're really going to see with this is lead. So even though lead is technically in the main group, it can have different charges, so we say lead 2. Okay, so just throwing that out there. Okay. I think I have some practice. Okay, so let's name these ions.
Let's do this.
Okay. Let's go. Let's start with the name and give me the ion. So if I told you sodium
I'll
ion.
start with me.
Oh, I mean, I wasn't going to call in anyone, but I could.
No, thank you.
Okay. To the class generically, if I said sodium ion, what would the charge be? Because it's in the main group, and you know based on where it is. Okay. If I just said magnesium ion, it's +2 because it's in group 2. Okay. Calcium ion, also +2. What about aluminum? It's over there in the +3 column. Okay. And lithium, it's +1. Okay. And notice the charge is not given in the name because it's obvious to every chemist, including you guys, based on it being in the main group, one of those columns. Okay, so we just name it its normal name. Okay, let's do some more. Okay, if I said chloride ion, do we know its charge? -1. Bromide? Also a -1. Phosphide? Looks like a -3 to me. Oxide?
But I thought you said they wouldn't be negative.
They're negative because of the column they're in. Notice these are not transition metals. Transition metals will not be negative. Non-metals will very commonly be. What charge is sulfide? -2, okay? Again, they're not transition metals, so I don't need to put the charge in the name, but they're anions, so I change the ending, okay? Anions have the IDE ending. Okay. What do you think? Question? Or do you say so cool?
I said so cool.
Okay. Agreed. Okay. So now I got some transition metals. Notice the charge is given in the name. Okay. So the charge is pretty easy because it's in the name. So iron 2 is a +2. Iron 3 is a +3. Zinc 2 is a +2. Mercury 2. What number is that for chromium? 4. Chromium 4 is a +4. Titanium 2 is a +2. Right? And it's always positive. Okay, for this system. Okay, you feel okay with this?
Not yet.
Not yet? Okay. Well, as you are getting comfortable with it, what we're going to do is we're talking about how to name ions. Then what we're going to do is we're going to put these ions together so that we can name ionic compounds. Okay. So basically, an ionic compound is you pick a positive ion and a negative ion, you put them together, and there's your compound. Okay. Is basically what we're doing. Okay, so if we can name the parts, we can name the whole thing. Do I have more examples? Or are we almost... Okay, so there we go. So if I give you a chemical formula, then it's just 2 easy steps to name it. Okay? So if I give you this, okay, I can look at that. I could look at my electronegativity difference. Should be greater than 1.7. Or I can look at it and go, that's a metal, that's a non-metal, it's probably ionic. So I'm going to name this using our ionic system. Okay, step 1, name the cation. What's the name of K+? What do I call that ion?
Potassium.
Potassium. Great. Okay, if it's in the main group, I use its normal name. If it's a transition metal, I need the Roman numeral. Okay, step 2, very easy, name the anion. What's the name of Cl-?
Chloride.
Chloride. Okay, IDE ending. So the name of this compound is potassium chloride. There you go. You just name the parts. We're getting close. Okay, I'll let you write this down and then I'll go through the examples kind of fast so we can do the other part. Okay, so I like to put little step by step in case you forget how to do it. You can come back to these steps and it'll walk you through. Okay, should we do some examples? Okay, we'll talk about the subscripts in a second, but those are not part of the name. I name the cation, name the anion. Okay, so that is sodium, Cl- is chloride, so the name of this compound is sodium chloride. There you go.
Salt.
Table salt, yeah, exactly. Okay, technically they're all salts, but this is table salt. Okay, Mg is magnesium. This one is bromide, so it's magnesium bromide. You'll also notice a pattern, and I'll talk about this in the next couple slides. The positive one comes first, the negative one comes second. So if they're next to each other, it's positive, negative. Okay, so again, they all end in the IDE ending. Okay, next one, calcium and phosphide, so calcium phosphide. Okay, this is aluminum and oxide, so it's aluminum oxide, lithium and sulfide, lithium sulfide. Name the cation, name the anion, put it together. Okay, so we've got those. If I have a transition metal, and again, you're going to have to recognize this, I won't necessarily tell you. Oops. Okay, I'm going to have to remember to include the Roman numeral to indicate its charge. Okay, now we need to figure out what charge it is. Okay, so we're going to have to do a little bit of deductive reasoning here. Okay, so I know this is iron, I know this is oxide, and I know iron is a transition metal, so it needs a Roman numeral. We kind of have to think logically to figure out what its charge would be. Okay, and you'll get quicker at this as you go. Okay, I don't necessarily know what charge this has, but I can figure it out based on what it's bonded to. Do I know what charge oxide is? I do, because it's in the main group. What charge is oxide?
Minus.
Okay, so this is a -2, and if it's bonded to an iron, then they have to cancel. What do we think the iron's charge is? +2. So then the name of the compound is iron 2 oxide. Okay, here I have iron and oxide again, but look, the ratio is different. So this probably means the iron has a different charge. Let's see if we can figure it out. Okay, do I know the charge of oxygen or oxide? So minus 2, right? Okay. Now what I also have to keep in mind is that there's 3 of them. So I have 3 oxides bonded with 2 irons. Okay? The total charges, yeah, need to cancel out. So my total negative charge is negative 6, which means my total positive charge has to be positive 6. So what charge do these individual ions have to be? Positive 3. Okay, we see that all these cancel and these cancel. So I'm going to name the ion. I'm naming that. So this is iron 3. Okay? Notice, this is the charge. This is not the subscript. Okay? You can't just look at that number and name it based on that. You name it based on the charge that each individual atom is. Okay? Stop me if you have questions. Are we okay with that? Okay? So the next one, what's M in? Manganese. Okay, so I have 1 manganese, 2 chlorides. I know based on the periodic table that chloride is minus 1. Okay. So my manganese probably needs to be plus 2 to cancel those out. So this compound is manganese 2 chloride. These ones take a little more work, but it's doable. Okay? What should I call this one? Manganese 7. Yeah. If I have 7 chlorides and this 1 manganese has to cancel them out, it's going to be a positive 7 charge. It's a big charge for 1 atom, but I think it can handle it. Okay? I'm just moving through these. So here I have chromium and fluoride. There's 3 of them. I know based on the periodic table that these are each minus 1. Okay, and so I just know that this chromium needs to be a plus 3. Okay, so that's chromium 3 fluoride. Titanium and sulfide. Sulfide's a minus 2. I think I heard someone say it. So then titanium needs to be a positive 2 because there's just 1 of each. So that's titanium 2 sulfide. Kind of makes sense? Let me do the next part, and then we'll do all the worksheet and all that stuff tomorrow. Okay? Okay, last part. If we're going from the name to the formula, we got to follow these steps. Or wait, what? Yeah, okay, sorry. I confused myself. Okay, so if I give you some names, you need to be able to figure out the chemical formula. Okay? These are the steps we're going to follow. We need to figure out the charge of each ion. How many do I need to make a neutral compound? So we're always going to be neutral. Okay, and then I'm going to write the chemical formula: cation first, anion second. Okay, so here, I'm going to back up. I'm going to show you, and then I'll let you write it down. Okay, so the first thing I want to know, if I just say potassium oxide, the first thing you need to know is what charge are the ions. I know potassium's K, I know oxide is O, but what charge do they have? How do I figure it out? The charge isn't given to me. It's on the periodic table, right? Potassium is +1, oxide is a -2. Do those cancel as are? No. So then the next step is I need to adjust how many of each I have so that they cancel out. What do I need to adjust here? I need 1 more potassium, right? So I need 2 potassiums to cancel out with that oxide. So the chemical formula is all of this together. K2O. That's potassium oxide. Okay? Iron 2 oxide. I know iron is Fe. I know oxide is O. Do I know the charges? What's the charge of oxide? Still -2. Okay, it's in group 16. Okay. Iron. It's transition metal. How do I know what its charge is? It's in the name. Yeah, that's the whole point. It's iron 2. It's given to us right there. So those cancel out, so iron 2 oxide is that. Okay, so that's how we're going to do that. Okay, so if you want, I'll give you a few seconds to write that down, but I wanted to show you while you're not right. Last thing I have is just some examples, okay? I'm going to go through them kind of fast, okay? Strontium fluoride. I know strontium is Sr. I know fluoride is F. I know that these are in the main group, so based on the group they're in, I know their charge. I know strontium is +2, fluoride is a -1. In order to make those cancel, I need 2 fluorides, so it's going to be SrF2, strontium fluoride, okay? Rubidium is Rb, chloride is Cl. This is a +1, that's a -1. I know that from the periodic table. So they cancel as is, so the chemical formula is RbCl. Okay? Lithium is Li, oxide is O. That's a 2-, that's +1. To make that cancel, I need 2 of these. So that's Li2O. Magnesium is Mg, nitride is In. This is a +2, this is a -3. Do you remember our least common multiples from elementary school? 2 and 3, I need to get to 6, so I need to get to +6 and -6 to make this all work, right? So I need 3 magnesiums and 2 nitrides. So magnesium nitride is Mg3N2, okay? Aluminum is Al, phosphide is P. That's a 3+, that's a 3-. They cancel out, so it's just Alp. Alp. Questions? Okay. Transition metals and we're done. Okay, these are the easy ones because the charge is given. Chromium is Cr, fluoride is F. The charge is right there. That's +6. Fluoride is -1. Geez, to make this cancel, I need 6 of these. Okay, so that's CrF6. Copper 2 is that. Bromide, I know the charge of that based on the periodic table. Bromide is -1. Okay, so I need 2 bromides to make that cancel. CuBr2, okay. Silver, symbol for silver, do you remember this? Ag, there you go. That's Ag +1. Okay. Chloride is -1, okay, so just AgCl. Side note, silver is a transition metal, but it only makes 1 charge. So some chemists are lazy and don't put this, they just say silver chloride, because silver only does a +1, so some people are lazy about that. Okay, tin is Sn, that's a 4, so that means it's a +4 charge. Sulfide is a 2-. If I want those to cancel, I need another sulfide, so that's SnS2, okay? Nickel is Ni, that's a +4 charge. Oxide is a -2. I need 2 of those to make it cancel. So nickel 4 oxide looks like that, okay? Again, notice the parentheses is the charge. It is not the subscript. Notice how these subscripts do not match this Roman numeral. Okay, a lot of people get confused with that, okay? Finish just in time. We will do some practice tomorrow. I will print it now if you want to hang out and wait a minute, or just come back sometime and I'll give it to you.
I'll just come back.
Sounds good.